A couple more sheet metal. Alright, so 80 does not show any bends. So there's going to be at least a 5mm bend, and with 5mm thickness, 10mm to the outside. These are showing the bends, but the numbers don't quite add up, so we're going to go with that internal and let the external end up wherever it may. So one more quick comment on 80. Notice that the 48 is up and over and the 32 is up and over. And again, that's kind of a weird way to do it, but it puts it into puts it into a usable location, but still have reservations about dimensioning it that way. Pretty much would dimension those on the flat pattern and just detail the overalls, tolerances and whatnot on the drawing. All right, so we're back into metric. We'll draw it from the front plane, putting the lower edge on the origin. Dimensions are to the outside. So pretty much 25 and 20. Nope, that one was 25, that one was 20. Alright, and then we have an overall height of 60. And let's see, and an overall length of 60. Okay, just quick double check. We'll go into the sheet metal base flange. We're going to stay with the 5mm. Go back normal 2. The direction is to the outside, so we're going to reverse it. 60 is called out as reference, so 16 and 16, 32 and 28 comes up to 60. So just a quick check of the numbers. Let's go mid-plane and give it our steps. Alright, for the let's go with the blocks or the notches. So we'll set those to the origin, midpoint, and we said that was a width of 28 and a depth of 10, and that can be extruded cut to just the thickness of the material. Go to the top. Alright, so the origin isn't available there. We'll select midpoint. Control select the edge, go to its midpoint. Width is also 28, depth is 15. So we'll get the easy ones out of the way. Features, extrude cut, and length to thickness. And it's more habit going back to, but if we looked across here, there's the extruded cut. So I don't necessarily have to jump back to features each time. It's just kind of a habit. So M8 and M8. Or those M6s. Fuzzed out again on the scan, so since it's a 5mm, yeah, I'm going to go with M6. Alright, so that being the case, let's just go ahead and include the holes in the cut. And I'll just drop in a center line for convenience. Go ahead and mirror. 6mm, 5mm, and then 8mm. That looks pretty good. Go ahead and accept because it's already in the feature. We'll go back into the next sketch. Okay, pretty much the same thing. Center line from midpoint and mirror, set our dimension. Alright, so that one I really can't read. We'll go with the, well, let's just say if that one was larger and it went 8 by 8. Looks okay. Let's go ahead and accept. Alright, and then we need to generate some geometry, so just on that, that sketch, come up and over, and up and over. See, that one didn't look like it got vertical, but we'll go coincident just to make sure. Nope, don't see it over in the group, so outside is 48 and inside is 32. Okay, so I'm just basic referencing back to the origin. That gives it position on the face, and then we'll have our center lines pick up coincident, come across. And let's see, they are 12, and don't see a dimension vertically, but it looks like a square pattern, so we're going to go with the square pattern. So that being the case, let's see how we can generate that. Okay, Control 8. Equals. And if we were to go center line and cross, then those two center lines could be equal. Those two need to be vertical. And those need to be vertical. Alright, so they're not moving strange. Let's go with a point at the intersection, midpoint. And then that can be vertical. Let's get our dimensions in. And that is 12 millimeters. Alright, so they're staying equal, but you have the distance that way. So that being the case, let's go with the split entities. Alright, so split entities is under Tools, Sketch Tools, and then Split Entities. And I'm going to split those out here. So basically all I'm doing is creating a break in the line so that I can come back. Thought maybe I could get it with the angle, but I need that segment and that segment to be equal. Alright, Extrude Cut. Link to thickness, and okay, we're through with the sketch. So maybe position. Yeah, something that makes sense. Doesn't just leave it hanging there as a sketch that don't know what it might be doing. 4-80. Alright, so we've been through this piece a couple of times. Oh. And they took at least in this one, they took the consider shell. There's no shell here. Consider sheet metal. Coming back and around to the outside shape. So, and this is still in metric. so let's go front plane. I'll just create the box. And I can always trim it out later. So 35 on the height, 45 on the width. Let's see if we were to split those entities yet again, then I could just make those construction lines and they won't participate. Height then becomes, well, I can see the length, so 35. Okay, looks like 18 on the step here and 35. So the issue with that small of a gap is how we're going to get in there and bend it. If we bend this and then go into the middle, are we going to have enough room with an offset die to get into a 90 degree, or are we going to have to do something different? Do we have the capability of bending something with that small of an opening? All right, and it's going to close up even more because those were the outside dimensions. And we're going to be telling it to go to the interior. All right, so sure enough, it goes to the outside. In condition is 480. And I'm going to stay mid-plane. Thickness is 5. It says fillets and rounds are 3. So we'll put a radius of 3 in here. That all looks pretty good. All right, so we can go to the notches. The notch goes around. They're saying 12 millimeters, so we can either try and cut that all the way through, or we could unfold it. All right, so let's just go sketch. We'll see what it looks like. All right, so select midpoint, go to midpoint. Width is, we're at 40, and depth is 12. All right, so a little bit past the bend line. So let's go ahead and extrude. Let's use, I need to get in the habit of using the cut extrude if I'm on that side. So linking to thickness doesn't really help there. So how about an up to next? And not really a through all both. There's nothing to terminate the feature going that way. So there's the notch. And then we'll go to the top. And it's also going to be, well, not called out, but also going to be 40. All right, so collinear and 25 deep. Yeah, 25. And then this one can be linked to the thickness. Picks up the geometry just outside of the radius. Okay, so hole locations, 8 millimeters, 4 places. All right, so let's go with the top, so we know we can get those in there. Now I'll go ahead and put it in horizontal, infinite length, and a miss. A mirror. $12 in and 10 millimeters over. Let's see, back into the sheet metal, extrude cut, link to thickness is fine. All right, so with the radius of 8 millimeters, 3 millimeters on the interior, 5 millimeters to the outside, and we're coming up or down from the bottom 8 millimeters, that's going to put it at 10 millimeters. We know that that's going to be through that wall. All right, so before I do the edge though, let's go ahead with the interior window. And it was 50. All right, for this one, we'll just go ahead with the center line from the origin up. Make it vertical. And distance of 12. And from the base was 10. Okay, so let's go ahead and cut extrude that. Length to thickness is fine, so we still have some radiuses. Alright, so we know that this is going to deform over that edge. It should cut through, but it really comes back to, are we going to cut it before or after? We really wouldn't want to do a secondary process, but the other side is I don't want a deformed hole there depending on what it is attaching the clearance. So if we had more information, we could make a better decision. So let's look at one in the folded state. And so those are 8 millimeters and 8 millimeters down and 10 millimeters in. And grab the radius, which I'm not real fond of. So we'll do that. Features extrude cut and blind in condition to the thickness. Well, I kind of expected it to stop at the radius, and it did. So edit feature, instead of, we're going to go up to next, so that it finds its way through. Alright, so if we were to unfold this, back over to sheet metal, unfold, don't really need all of the bends. Let's see if it'll collect just the one. Okay, it flattens that one out. You can kind of see the deformation of the flat pattern. And so if this one goes to an 8 millimeter, and 8 millimeters from the edge, and 10 millimeters in. Then jumping back over into sheet metal, extrude cut, stay linked to thickness, and then we want to fold that bend back up. Cannot be unbent. Alright, so so it doesn't like where I put the hole. Fixed face is okay. And the base bend has that intersection, so the deformation is going to be okay. So let's see. Let's bring that up to 6 millimeters and see if it can complete. Alright, so fold it back up, collect all the bends. Interesting. Okay, so that was okay. That was okay. Let's see if it'll fold back up from here. Alright, so let's suppress the last hole. I haven't seen it do that before, so fold, all bends. Alright, so unfolding and refolding, that means that as long as I'm not violating parent-child relation, then I can go ahead and unsuppress that one, so that we can look at the difference between the two geometries. Alright, so let's put that back at 8 and make sure it rebuilds okay. Alright, so teardrop to the outside and teardrop to the inside when it's unfolded. So as drilling holes and the folded up position have some backing. This would be the preference if we're drilling them flat. And putting up with that little bit of deformation, maybe run an end mill or a drill through that to clean it up. Those would be our two choices, just to see the difference in the geometry. Okay, so we're going to go to a fillet and 3 millimeters. I'm going to pick the next one, and then we'll look along. No. That one would be maybe internals. Let's say that one, but just enough extra there to say no. But okay, taking out one, I'm okay with that. All right, so 4-81. Save. All right, so let's scroll down to the next, to where we can see next piece. All right, so this one has some thickness. This is going to take an iron worker or some serious tonnage to bend if we do this as a sheet metal piece. The other thing is no square corner. So that being the case, this kind of goes over to machined, and the angle, if that angle is straight through, and kind of hard to tell if it's back angled or if it's straight, we're going to make this one convenient and go straight through. All right, so step up and over, and then we'll put in the fillet. All right, so we're still in metric. Let's go sketch on the front plane and come over, and radius of 30 in 2 places. All right, so 70 to the intersection, back up and over. All right, so 28 to the outside. Okay, and that's looking like a vertical. All right, so let me get those parallel. All right, so between the parallels, material thickness is 12. And we'll go same thing here just to make sure. Our overall height is 45. And we're going to put in one more 12. All right, so from the intersection out to the vertex is 28. And what did we do for a height? All right, so material thickness 12, then based on the angle, that's not going to be 12 unless it kicks back, which it doesn't really kick back. If we're doing a bend and on the geometry, then yeah, we would expect it to come back at an angle. If I put a driven dimension on it, then 14. No. I'll just go ahead and delete that one out. So this is capable of moving up and down. So from our dimension, from there to there, 25. All right, and then if we were to go back to that one, 12.93, it's still almost a millimeter longer on that edge because we haven't cut it back to an angle, which further makes me think we're not going to bend this. All right, extrude. Let's stay with the mid plane. Overall is 50. All right, the couple of holes. We'll do the pocket through. Let's bring up the center line and miss the origin. All right, and then that becomes horizontal. All right, 20 on the width. 15 on the sides. All right, so driven dimension. And then it's giving a 15 from okay, that's looking more like an Escher, but where it comes in. So let's go 15 from the edge. We'll get that much. All right, 15 from... That is still really strange that they didn't pull that from the vertex. Because even coming back here, I made a 14 there, it's going to put it pretty close, so that number's a little bit of a concern. So let's roll back. And offset a line, and even 10. Okay, and I can make that a construction line. All right, and if we look from there to there, and go over to our evaluate and measure, it's about 19 millimeters. So rebuild. One more check. So 14.8. So not quite 5. We're going to go 6 and leave it. All right, so again, depending on what this is going to do, how much that clearance is actually affected by that number. All right, then we can go collinear. And the other issue is, again, we may get this part and it's cut back, and then we have a different process that we'll see on the next one. Features, extrude cut. Let's go through all. All right, and then the 2 holes. And 10 millimeters on the diameter. Features, extrude cut. And let's just go up to next. All right, so what's left is fillet, 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 fillet. They're saying those are 3, and then the top ones are 30, so yeah, it's kind of strange, but whatever. All right, and then there to there, we'll go to 30. Got to quit hitting the Windows key. All right, so the leg over, down, hide the sketch. We'll give this a position. And hide it so that it cleans up. And Control Save. P4-82. All right, on to the next one. Okay, so this angle has 50 to 40 to 53. They're staying consistent, so it could consider it a bend, but the sharps, this thing's going to be kind of a pain to machine anyway, so and fabricate whichever way we go with it. So new metric. So we may just offset and cap the ends on this one. So let's come off of and back and up. All right, and that one says parallel, but I don't trust it to be parallel. So we're going to pick our numbers. All right, so based on the dimension they gave us, this is 30. And then that was flat. And then 30. So not quite. 50 on the length, 40, bring it back, and 53. All right, so that being the case, I'm going to go ahead with the offset entities, make sure to select the chain, reverse the dimension, 10 millimeters is okay, cap the ends and make sure that they're lines, and there's our geometry. Features, extrude, and we're going to go to 40 millimeters, still staying midplane. Alright, so the two holes on the bottom. Get into the sketch. Those equal. We can go vertical to the origin, so I don't need a center line. Dimensions then are 20 and 15. And the diameter is 10 millimeters. Go with the features, extrude cut. There's no sheet metal, so it won't automatically go to length to thickness. Alright, so sketch then. Well, we need to be just far enough past the bend that we can intersect the two geometries. So 16 millimeters. And then select the midpoint, select the origin. Those can be horizontal. Alright, 13 millimeters off of the end. Well, off the bend, or off the off the edge. And then let's just go far enough past. We'll do another 13. Features, extrude cut, through all both. Because we're low, we want to make sure that that gets up high enough. Alright, on the next phase, we pick, and I'm just going to go right to that vertex. And then the dimension back is 20. Extrude cut, and through all. That makes the geometry. So even with, setting this up, machining this out, even with, I need at least a radius on the interior. And they did not include any on this one. 3 millimeters is on the small side, but I could get a 1/4 inch end mill in there. And be pretty close. So let's just see the interiors. Okay, we'll go with all of the concave and then just remove that one. Oh, it added 2 more. Just saw those. Alright, so that one and that one can go away. So about as easy just to pick the 4. Oops. About as easy just to pick the 4 inside edges than try to fit all of those in. Alright, 4-83.